Hello, Programming 11. Welcome back to the Pew Pew game. We're building this crazy game here, which involves shooting. And what we've got so far is a player that moves around with the keys, and we have bullets that fly straight out of the character, the player, and go straight up. We've done quite a bit of work considering how simple this game is. Our biggest achievements so far in the project have been making the game object class, which is a class that is the foundation for all the other objects that are going to be in the game. The player, the bullet, they're all based on the foundation of the game object. Which allows us to not program so much. We can, centralize all the things that are common inside of the game object class. And then our player and our bullet class can be a lot smaller, and all the future classes we're going to make as well. Also, we made a beautiful loop that allows us to process all the game objects. Because all the classes are based on the same foundation, we can just have a list of game objects as opposed to a separate list of bullets and a separate list of enemies and so on. So this loop here is what you could refer to as a game engine. It is the engine that drives all the things that are happening in the games, all the interactions, all the movement, all the visualization. This loop does it all. So that's pretty exciting, but we have this foundation to work from. We haven't done a lot with it yet, and we're not going to do a huge amount in this video. We're just going to add on one interesting new thing into the bullet, and that's we're going to make it so that we can aim the bullet. So as you can recall, we just click the mouse to shoot, but it just always goes up. What I'd like to do is make it so that the bullet will point at the mouse. So right now we're aiming using Vx and Vy. This is why it's going straight up. Vx is 0, Vy is -10. What the heck are these Vx and Vys anyways? Well, remember in the game object we have that programmed in. This is what happens. We're constantly changing x by the Vx, and we're constantly changing y by the Vy. So if this is 0, that means x isn't going to change. And if it's -10, then y is going to be decreasing, which is why these velocities, Vx 0, Vy -10, result in going straight up. Because the y coordinate's getting smaller and smaller, and x isn't changing at all. So, we'd like to change it so that we can point to the mouse cursor. So we need a rise and run of what's happening in our direction, the line that you could make between the mouse pointer and the character. So I'm just going to turn something on. This isn't something you need to have. If you like it, you can put it on as well. I added the show function into the player, which we didn't have before. We had it so that it was sort of already in the superclass, but I've just added it in and overrode it, I guess. I'm not sure what the past tense is. Put in super.show, and then I've added in this little bit of code here. You can put it in or not. It's not important. I'm going to delete it later. But what it just does is help us visualize that Vx and Vy. So as I move my mouse around, we can see that there's the black line is our Vx and the white line is our Vy. At least based on the mouse. So how is it that we're going to get those numbers? It would be wonderful if we can get those numbers, and it's simply going to be the difference between the mouse's coordinates and the player's coordinates. To get that white line, it's just going to be the difference between the mouse pointer and the player's pointer. So the mouse's x-coordinate. No. Let me try again. The white line is going to be the difference of the y coordinates. The mouse y minus the player's y. And the black line, the Vx, that's going to be the difference between the x coordinates. It's going to be the difference between mouse x and the player's x. Oh, that was hard to say. Sorry, that was confusing. Let's put it in. And you're going to see that this doesn't quite work. So hang in there. Don't just type it in and quit the video. We got more work to do. But it's a start. So I'm going to put in Vx is the difference between mouse x and player's x. I'll just put in x. I guess that would be player's x, wouldn't it? So my player dot x. And the Vy is going to be the difference between mouse y and player dot y. So let's take a look and see how this looks. So you can see we can shoot bullets, but look how fast they go. They go so very fast, like really fast. Especially if I go further out. Do you see why that is? it's calculating a Vx, and see where the first bullet goes? It goes straight to my mouse pointer. Because our Vx and Vy are so very big. The bigger I get, like the fewer bullets you see. If I get really tight in there, I can finally slow the bullets down. I can almost get them to be motionless if I could get the mouse directly over. I think I got one motionless one. Now this doesn't make sense. Like your speed of your bullet shouldn't be dependent on a particular way of aiming your bullets. Although I guess I could see that as possibly an interesting mechanic. But I don't want that to be the case. So what are we going to do? How are we going to make this actually work so that we don't have like variety of speed of bullets? So the problem is that this number changes depending on the mouse. And one solution, this is what we did before, is we divided it by a constant. That worked in the Brick Breaker game because things were constant. The distances between the mouse, the ball and the paddle, for example, they were always the same. But now, like if we divide by 10 or something, we'll get somewhat more reasonable behavior. But it still doesn't really solve the problem. It still changes as I get further and further away. Again, I could see a cool game where that's actually a mechanic and you actually care about that kind of thing, but that's not going to be this game. We're going to try and do it a little bit better. So I don't want a variety of speeds. So here's the deal. This could be solved with trigonometry. You could, basically set the hypotenuse by finding angles and using sort of tangent to find the angle, and then with the angle, basically get a hypotenuse to be set as a certain length and calculate the Vx and Vy from there. Maybe you could even see how that could be a right triangle no matter where you go. So there is one solution is just simply to use trigonometry to do this. And if this was a math class, I would totally be down with that. I think that'd be great. I remember some of us actually did trigonometry. Remember that class? Some of you were in that Ms. Holman's math class, and I was the substitute teacher randomly. It was so fun. But we're not going to do the trig because processing and many programming languages have a built-in structure called a PVector. And a PVector basically is going to just store Vx and Vy, and you can calculate it, and that's great. But then it has some special abilities that allow you to like set the speed basically of the thing. So a PVector is kind of like it's just a Vx and Vy kind of put together. So I'm going to do it right now. I'm going to make a PVector. It's going to be called aim. I could call it V actually, I guess. I don't know. I'll call it the aim. And again, a vector is like an arrow. It's just got an x and a y coordinate. Really, it's nothing really fancy. It's just pretty much the same as Vx and Vy. So I'm going to make a new PVector. And for the x, it's basically got an x and y component. For the x component, I'm not going to put x there. I'm going to put in. Actually, sure, I'll do that. I'm going to take this. This is what I want. I'm going to take this part here and put that in the x component, and this part here I'm going to put in the y component. And then the way we get it out is to say aim.x and aim.y. I just want to show you that nothing has really changed. If I do this and then semicolon, and then I from aim, I then just take out the x and y components. It's exactly the same as what we had before. If I click, you can see that the bullets are working just the same way. So this PVector hasn't really done anything new, but now we can add in something new. Check this out. We can say aim.setMag, which stands for magnitude. And we can set it to a particular number. So what's really nice about aim, PVectors in general, is that you can sort of treat the speed and direction separately. And it uses trigonometry to do this, but we don't have to get our hands dirty with trigonometry. So now that we have this, you can see that like they're all coming out at the same speed. No matter how far away my mouse is, it's choosing a Vx and Vy in the correct direction, but only has a length of 10 for that hypotenuse of that triangle. It doesn't matter how small or far away it is. It's doing that calculation for us. So that's how we're going to do aiming. We're going to use this PVector stuff. So PVectors, again, not necessarily anything super different. It's a object that has an X and Y component, but we can scale it. There's other things we can do too in the future. You can rotate it, and you can do some other fancy things with it. We don't need to do that for this particular example, but we'll probably explore PVectors a little bit more as we go. Okay, so that's aiming bullets. I hope you're finding this project fun and interesting. Our next video, we're going to add in something to shoot at, and I mean, maybe we'll blow it up, but eventually we'll have the ball bouncing off of it, which will be really fun. Some obstacles or something. Before I go, I'm just going to turn these off so it won't mess up our next video, and I hope everybody has a good day. Take care.